It's another study with me, boys. I think this is good. This is alright. Nah. Alright, so I'm gonna be studying now, and you guys are gonna study with me. You have to study with me, you know. Studying is what we do. We learn knowledge. We gain knowledge. We don't learn knowledge, we gain knowledge. So, open link in a new tab. How do you do that? Wait, just wait. Okay, this. Wait, page down. No, wait. That took me a long time. Just wait, hold on, bro. This is so. Okay.
Going to focus on drawing constitutional isomers. A constitutional isomer is basically a molecule that has the same chemical formula as another molecule, but have a different structure, different connectivity. So, for example, how can we draw the constitutional isomer of, let's say, butane? Now we have 4 carbons in a
Studying that. I'm studying something different.
This video to look at this video is going to look at the topic of isomers for alkanes and alkenes. Now I've drawn out here the first 4 alkanes, which you should now be able to name. So we've got methane with 1 carbon, ethane with 2 carbons, propane with 3 carbons, and butane with 4 carbons in the chain. Now, the first 3 alkanes, methane, ethane, propane, there's only one structure that you can have for them. There is no other alternative. So with butane, there's more than one structure that you can have. Now, one option is to just draw straight butane with 4 carbons in a chain. Another option is to move this group here and switch it over with one of the hydrogens in the middle. So if I draw that one out now, so we've got 3 carbons in a chain, so these first 3 here, but I'm switching this carbon and this hydrogen over, we can have a slightly different structure. It still has the same number of each type of atoms in it. It's still got 4 carbons and 10 hydrogens, so it's still got the same molecular formula, but this time we have a slightly different structure. Now this structure is called 2-methyl propane. Now the reason for this, we've got 3 carbons in a long chain. That's where the propane comes from. Just like propane has 3 carbons in one long chain. But this time, off the side of that chain, we've got a different group with one carbon in it. So it's a side group, which is a methyl group. Now that's carbon 1 and that's carbon 2. So that's where the number comes from to give it 2-methylpropane. Now these two structures, they have the same molecular formula, but they have a different displayed formula or a different structural formula. So here it's absolutely vital that you learn this definition. Structural isomers have the same molecular formula, but a different structural formula. In our next example, we're going to have a look at the isomers of pentane. So, if we have a look at the first example here, we've got one straight long chain here with 5 carbons in it. So our molecular formula here is C5H12. If we have a look at our second example here, this time we've got 4 carbons in a long chain, and then we've got one side group here off of that main long chain. So this one, on the second carbon, that's carbon 2, that's carbon 1, 2-methyl butane. So we've got the butane part from 4 carbons in one long chain, and then 2-methyl, so off the second carbon here, we've got our methyl group. If we look at the molecular formula is exactly the same. It's got the same number of carbons and the same number of hydrogens. So they fit our definition, same molecular formula, but a different structural formula. Now you might be wondering, well, what would happen if I moved this methyl group and switched the 2 over? So I put it there instead. This doesn't actually change the name at all. Now, instead of naming this as carbon 1, now you would just simply name this one here as carbon 1. So this would be 1, this one's 2, this one's 3, and now this one's 4. Now the reason why you do this is because the molecule is actually rotating. So this molecule is rotating around and spinning over. So no matter where you draw it on this molecule, if you draw it there or there, it's still on carbon 2. Now if we look at alkenes, again we can have structural isomers of them. Now for the first 2 alkenes, so ethene and propene, again, there's actually not going to be any alternative structures to these as alkenes. There are alternatives that you can study at A-level, but here focusing at GCSE, there is no other structure that you can have for either of these two. Once you start getting 4 carbons again, we can now have a different structure. Now, in this situation, we've still got the same molecular formula, so we've got C4H8 is the molecular formula of butene, but this time we can have the double bond in a different position. So in this example, on carbon 1, that's where we find our double bond. But we can switch these two over and we can have the double bond on the second carbon in butene. So if I just draw out now butene, another example. Now in this example, we've still got the same molecular formula, it's still C4H8, but now our double bond is on the second carbon in the chain. So this one is called but2ene, and that's because our double bond is found on the second carbon here in the chain. And again, it doesn't matter which end you start from. If you start from this end, it's still going to be on carbon 2. If you start from this end, it's still going to be on carbon 2. So if this is but2ene, that means this one should actually be called but1ene, because the double bond here is found on the first carbon in this chain. So all you have to do is choose an end to number from and keep the number as low as you possibly can. So I hope that helps you look at alkenes and alkanes. There is a lot more that you can look at on this topic, but this is just an absolute basic introduction.
fuck is going on? Look, I have no idea why my microphone is not working. What the fuck is going on? Look, I have no idea why my microphone is not working. Is my microphone? Yo, what's up, bro? Is my microphone working? Like, I have no idea. Yo, 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 yo. Yeah, is my microphone working, bro? Look, I have no idea what's going on. Okay, I think there's some technical issues, technically difficulties that my microphone is not working. For some reason, it's not working. I don't even know why. Is it? It's working? Damn, alright. Okay, good. Thank you, thank you, thank you for telling me that. Thank you for subbing me as well. I really appreciate it, bro. You don't even know how much I appreciate that. Alright, I'm gonna go back to studying now. Thank you for the like, thank you for the sub, everybody, thank you. You guys wanna see what I'm doing? There. I'm studying for high school. I'm in high school, I'm studying for my mids exams. I'm studying for high school. That was loud. I was gonna see how my microphone sounds like. That was loud. Okay, guys, tell me if you hear me when I do this. Is it okay? Is it okay? I just want to know that. Okay, it's okay. It's good. Alright. Just testing if the things are working fine. You know what I mean? Alright. Now I'm gonna see another video.
In today's video, we're going to take a look at hydrocarbons, and specifically at alkanes. First though, it's worth understanding that this whole area of chemistry is known as organic chemistry, which just means that it's all about compounds that contain carbon. You'll see over and over again in chemistry that carbon is a really useful element for making large compounds, because each atom of carbon can form 4 strong bonds, with the most common atoms we bonded to being either other carbon atoms or hydrogen atoms. Now, lots of molecules only contain these 2 elements, and collectively refer to all of these molecules as hydrocarbons, which we can define as any compound that's formed from carbon and hydrogen only. So this molecule, which is called butane, is a hydrocarbon, but this similar molecule, called butanol, isn't a hydrocarbon, because it also has an oxygen atom. The most simple type of hydrocarbons are a group called alkanes, and you need to know the first 4 in the series. The smallest is methane, which contains just a single carbon atom bonded to 4 hydrogens, because remember, carbons always have 4 bonds. Then we have ethane, with 2 carbons and 6 hydrogens, propane, which is C3H8, and butane, which is C4H10. Now, if you look at all of these compounds, you'll see that they grow by 1 carbon and 2 hydrogens each time, but otherwise they're pretty much the same. We call groups of organic compounds like this homologous series, and it means that they all have similar properties, and so react in a similar way. It also means that we can write a general formula, which describes the entire series, and in the case of alkanes, the general formula is CnH2n plus 2. This might look a bit complicated, but all it means is that if the compound contains n carbon atoms, then it will contain 2 times n plus 2 more atoms of hydrogen. So if we had an alkane with 3 carbon atoms, like propane, then n would be 3. So it would have to have 2 times 3 plus 2 hydrogen atoms.
8.
So 8 hydrogens, which would give it the formula C3H8. Now, you only need to remember these first 4, but you could be asked to use this general formula to work out the molecular formula of much larger ones. For example, octane is an alkane with 8 carbon atoms. What is this molecular formula? Well, we know that
It's easy.
will burn, as we'll see when we come to crude oil. The next thing we need to look at is combustion reactions. One of the main uses of hydrocarbons, like alkanes, is for fuel, because they release loads of energy when they're burned with oxygen. As long as there's enough oxygen available, we get complete combustion, which is when a hydrocarbon reacts with oxygen to form carbon dioxide and water, releasing loads of energy in the process. So we could say that it's an exothermic reaction. We could also say that the hydrogen and carbon in the hydrocarbon are being oxidized, as each of the elements is combining with oxygen to form CO2 and H2O respectively. Now, when it comes to exams, you need to be able to write out the equations and balance them. For example, you could be asked to write the balanced equation for the complete combustion of propane.
I don't know how to do that.
That propane is C3H8. So we'll react this with O2 to form CO2 and H2O. Then all we need to do is balance it. We know that on the left we have 3 carbons, so on the right we'll need 3 CO2s. We also have 8 hydrogens on the left. So because each H2O molecule contains 2 hydrogens, we know we'll need 4 of them on the right. Then lastly, we need to balance the oxygens.
Or organic
On the
chemistry.
right,
Organic chemistry is fire, but it's... I'm not understanding. I mean, it's alright, yeah.
we have 6 oxygens.
It's better
from the
than
CO2s,
other type of
plus
chemistry.
4 oxygens from the waters, so 10 in total. So to get 10 on the left, we'll need 5 oxygen molecules.
Oh yeah, I know how to do that.
With the properties with the shortest hydrocarbons having the lowest boiling points, and so being the most volatile and flammable, which makes them great fuels. First, anyways,
I know how to do that.
crude oil, and see how we can separate it into its different components using fractional distillation.
Something to my teeth.
Crude oil is a fossil fuel that we get from deep under the ground, and is basically a mixture of lots of different compounds. Nearly all of these compounds, though, are hydrocarbons, which contain only hydrogen and carbon. And the most common type of hydrocarbons are alkanes, which we covered in the last couple of videos. Now, crude oil is formed naturally from the remains of dead plants and animals, particularly plankton, that died millions of years ago.
Plankton? Bro, isn't that the dude from SpongeBob or something? I don't recognize that name, bro.
And were buried in the mud. Then, in the millions of years between then and now, the high pressures and temperatures under the ground turned this organic biomass into crude oil. As it formed, this crude oil soaked into the rocks and was stored for millions of years. But we can get it back out by drilling into the rock and sucking it up to the surface. As crude oil takes so long to form, it's effectively a finite resource. And if we continue to extract and use it at the rate that we are now, then one day we'll run out of it completely. This is why we refer to fossil fuels like coal, oil, and gas as non-renewable fuels. Once we've extracted the crude oil from the ground, we need some way to separate out all of the different hydrocarbons in the mixture, because they each have different properties, and so we'll use them for different things. To do this separating, we use a process called fractional distillation.
I know that. I studied that, yeah.
Which involves heating the crude oil up
And then put it
and
into a
separating out
distillation
different
flask.
compounds by making use of the fact that the different compounds all have different boiling points.
Yeah. Let me tell you, what happens is that different compounds have different boiling points, so we're just gonna get a flat distillation flask, and we're gonna get a fractionating column, and then we're gonna put it in the, and then we're gonna have a beaker, right, to collect the, out, like the purified, you know, the separate thing. Like if you're supposed to like, get crude oil, like we have to supposed to get like coal. Okay, I messed it up. But it's something like that.
The first step is to feed the oil into a chamber and heat it until most of it has turned into a gas.
We're gonna get a condenser as well.
We then pass this gaseous mixture into a fractionating column,
I knew that. See,
which is really hot at the bottom, but gets cooler towards the top. The idea is that these hot gases will then start to rise up the column.
okay.
But importantly, As soon as they reach a region that has a lower temperature than their boiling point, they'll condense into a liquid. The hydrocarbons with the longest chains, so the most
My mom
carbons,
was calling me. Alright, I'm back. Not that you guys cared, but only one person is watching. But alright, okay. It's alright. One is way better than 1,000, I guess. Alright, I'm back. Not that you guys cared, but only one person is watching. But it's alright, okay. It's alright. Wait, first of all, I want to change the bitrate to 4,000. I don't know why it's fluctuating like this, but I think I did something wrong. I need to go to the advanced, and I want to change to video for CPU render SDR. Wait, audio recording replay buffer stream delay, automatically reconnect network B8P, dynamically. No. Wait, I just want this to be at 4,000. No, 4,000. Okay, that's good. Bro, why is this happening, bro? Why is this happening? This is not going good for me. You also studying science? Bro literally said the most fire statement that one. Yeah, bro. You worth 1,000 to me. You worth 1,000 to me. No gonna lie. You worth 1,000 to me, bro. You worth 1,000 to me. Let's study together. Not that I want to study. I want to play chess. Alright.
at the highest boiling points, and so they'll quickly condense back into a liquid and drain out of the column early on, because it's not hot enough to keep them in their gaseous states.
What did you say? Wait, what did you say?
Into a region that has a lower temperature,
Uh-huh.
boiling point.
Yeah.
Condense into a liquid.
Okay.
The hydrocarbons with the longest chains, so the most carbons, have the highest boiling points.
They have the highest boiling
So
point.
they'll quickly condense back into a liquid and drain out of the column early on,
So they will.
because it's not hot
Okay.
enough to keep them in their gaseous states. These are things like bitumen, which we use to surface our roads, and
Bitumen.
heavy fuel oil, which can be separated further and used for things like heating oil fuel oil or lubricating oil.
Heavy oil, okay. They have the highest
Shorter chain
carbon.
hydrocarbons, though,
Sure.
have much lower boiling points.
Like
They
butane,
will stay as a
pentane,
gas for much longer
ethane.
as they rise up the column until they finally reach a cool enough temperature that they condense into a liquid. This gives us fuels like diesel and petrol, which we use in cars and other road vehicles,
Diesel, petrol,
and kerosene, which is
kerosene.
used in jet engines.
So you're saying that fractionating column is like used to there's like it's really hot at the bottom, but like it's really cool at the top. So the more that like the alkane that has more like the like the carbons, right? Like it, like bitumen, right? It will go up and it will cool down. It will condense like really quickly compared to the ones that have low boiling point, which means they have fewer carbons. Okay, I'm sick right now, as
Some
you didn't know,
hydrocarbons, though,
and I think like I'm losing it. I'm about to crash out.
are so short and have such low boiling points that they stay as a gas the entire time.
Oh, so like ethane, methane.
For example, LPG, which stands for liquefied petroleum gas, contains mainly propane and butane, which are both.
I too love chess, bro. Yes, bro, I love chess. Like for, oh my god, is the stream lagging? I think, bro. What did I get the message, bro? Look at this. What the frick is this? Hello, I'm in love with you. What? Bro. What is that supposed to mean? No. This is crazy for real. Wait, hold up, bro. I think I might be hacked. Has more, like the. What is that supposed to mean? Exactly. No. Wait, bro. No. This is crazy for real. Wait, bro. Generally, I'm not joking, bro. There was a girl. There was this like weird ass. Bro. What the frick is this, bro? What is this app's? Wait, what is this app? Oh, it's this app. Oh, this is a singing app. I have it, and I didn't even know that I have it. Wait, she's famous, bro. She has 149,000 likes. Damn, wait, how many followers does she have? No, wait. Let me see, bro. How many followers does she have? She has, what, bro? Damn. She has 600,000 fans. That's crazy, bro. Should I upload some music too? I have 18 followers. If you guys want to know. 60 gifts. Bro, I should be studying. What the fuck am I doing? Wait. I'm sorry. Yeah. You should be studying too. Yeah. No distractions. Only studying. Alright. She's famous, bro. She has 149,000 likes.
Very short chain alkanes. If we compare these different groups or fractions, the ones towards the top, which are the shorter chains, are the most flammable, and so they tend to make the best fuels.
So they're the most flammable, yeah.
Meanwhile, the longer chain hydrocarbons,
Yeah, they have the
also
most boiling
often
point,
poor
yeah.
fuels,
The poor fools, yeah,
are
like diesel.
instead either used for something else, or can be broken down into smaller hydrocarbons
I
in a
know.
process called cracking, which we'll take a look at in the next video.
Okay. Thank you. I appreciate this,
One thing
sir.
to point out is that as well as all of these very direct use,
So they can be broken down into smaller hydrocarbons. Okay, we call it Kraken.
Petrochemicals, which is what we call all these substances that we get from crude oil, can also be used as feedstock, which just means raw materials for the
So petrochemicals.
can
Wait,
also be used as, which is what we call any direct uses that we mentioned here.
wait, hold
Petrochemicals,
on.
which is what we call all of these substances that we get from crude oil.
Okay, we get substances from crude oil that are called petrochemicals, as written here in the book. Okay. And
Can also
yeah.
be used as feedstock.
Wait, what?
Substances that we
Feedstock?
get from crude oil can also be used as feedstock, which just means raw materials for the petrochemical industry.
Oh, raw material for the
These usually
pet. Okay.
make things like solvents, lubricants, polymers, and detergents.
Wait, so feedstock isn't okay.
Materials for the petrochemical industry. You use them to make things like solvents, lubricants, polymers, and detergents.
Alright. Yo, Captain Dam, where are you from, bro?
Video. So hope you found it useful. If you did, then please leave a like and subscribe. And we'll see you next time. Carbons. And that we can. We saw in the last video that we can think of crude oil as a mixture of lots of different hydrocarbons, and that we can separate out these different hydrocarbons by the length of their carbon chains using a process called fractional distillation. We also saw that the shortest hydrocarbons are the most flammable, and so they make the best fuels, whereas the longer chain hydrocarbons are thick, viscous liquids, which makes
Like
them
my dick.
comparatively
Okay,
less
no. That's bad. That's
are
bad.
thick, viscous liquids.
Wait, bro, I gotta help my sister out. Wait. I gotta help my sister out. Bro, I can't study, bro. This is what happens when I try to study. Message retracted. What did you say, bro? Wait, I gotta like upload it. Wait, hello, bro. I gotta help. I gotta do something real quick. I gotta do something real quick, bro. Yo, guys, I gotta do something real quick. It's gonna take 5 minutes. All right. Hopefully. I am back and I'm ready to become Einstein. Alright, let's do this. Alright, okay. Bro, I know, yo, dude, Captain. Sorry for the wait, guys. Alright, okay, now. Alright, now I'm gonna be continuing studying, which I really don't want to do right now because I'm really, really fried. Ah, sorry for the boring stream. I am trying to improve, but I can't find any, on some real shit, bro. Somebody just texted me, "Good morning, how are you?" Look, bro, I can't even show the number because it's gonna show mine. What the fuck is going on with my phone, bro? Like, what did I even do? Like, why am I getting these type of phone calls and shit, bro? Let me call this dude. Wait.
फॉर्मूला होता है C5H12, जिसमें हमारे पास 5 कार्बन एटम्स अगर मैं स्ट्रेट चेन में लगा दूं, ठीक है, इसके साथ पहले कार्बन के साथ 3 हाइड्रोजन
I was talking to my best friend on the call. Okay, my bad, guys. Yo, I was talking to my friend on the school, on the call. So yeah, best friend on the call. Okay, my bad, Captain Dan. My bad, bro. Captain Dan, I kept you waiting. I was on a call with my friend. My bad, guys. Yo, I was talking to my friend on the school, on the call. So yeah, I didn't really thought like was. I didn't really think what I was gonna do. So niggas, we calling me up. I caught it. यार इनमें से वो नशेड़ी आदमी तुझे नहीं पता इतने ज़्यादा तूने किए इलेक्ट्रिसिटी तब इलेक्ट्रिसिटी की है और इलेक्ट्रोमैग्नेटिज्म की है और इलेक्ट्रोमैग्नेटिज्म ओए अब्दुल्ला बिलाल ओए मेरी बात सुन ओए तेरा मतलब कि जो फेस शेप है वो तो भाई बड़ा पतला लग रहा है तो क्या हो गया डाइटिंग लगता है शुरू कर दी है कबाब जी के बगैर भाई मैं लीक नहीं कर रहा ये कौन सा मैंने इंस्टाग्राम की स्टोरी पे लगा दी है ये तो भाई हम जानते हैं फ्रेंड्स को ओ भाईजान मैं लीक नहीं कर रहा ये कौन सा मैंने कोई इंस्टाग्राम की स्टोरीज भी लगा दी है कोई 50 लोगों ने देख ली हुई है तो बस 4 लोगों ने देखी है मूल भी देख लेगा तेरा बेस्ट फ्रेंड ऊपर से मैंने कहना था भाई तेरा फेस शेप तो पतली हो गई हुई तो मुझे लगता है डाइटिंग करना शुरू कर दी है तूने कबाब जी इसके बाद ना मुझे लगता है तुमने ना शुरू कर दिया फिर ओ भाईजान मैं लीक नहीं कर रहा ये कौन सा मैंने कोई इंस्टाग्राम की स्टोरीज भी लगा दी है 50 लोगों ने देख ली हुई है तो बस 4 लोगों ने देखी है मूल भी देख लेगा तेरा बेस्ट फ्रेंड ऊपर से मैंने कहना था भाई तेरा फेस शेप तो पतली हो गई हुई तो मुझे लगता है डाइटिंग करना शुरू कर दी है तूने कबाब जी इसके बाद ना मुझे लगता है तुमने ना शुरू कर दिया फिर ओ भाईजान मैं लीक नहीं कर रहा ये कौन सा मैंने कोई इंस्टाग्राम की स्टोरीज भी लगा दी है 50 लोगों ने देख ली हुई है तो बस 4 लोगों ने देखी है मूल भी देख लेगा तेरा बेस्ट फ्रेंड ऊपर से मैंने कहना था भाई तेरा फेस शेप तो पतली हो गई हुई तो मुझे लगता है डाइटिंग करना शुरू कर दी है तूने कबाब जी इसके बाद ना मुझे लगता है तुमने ना शुरू कर दिया फिर